So in the last two lectures, we were looking at pointers. So I would just like to recap a couple of points. Like I said earlier, a pointer is a special kind of variable which is linked to other variable. Usually variables are not linked to other variables. Each variable will have some value and that's it, that's the end of it. But pointers are linked to other variables. How are they linked? It is by storing the address of another variable, right? Like if you remember, so each variable has these three parts: variable name, its value, and address. Similarly, a pointer is also a variable. It has some variable name, value, and address. It so happens that the value stored in the pointer variable happens to be the address of some other variable. That is how it is linked to another variable. That's all. Otherwise, variables in general, they are not linked to other variables. They are independent. But pointers are special variables because they are linked to other variables. How are they linked? By storing the address of other variables as their values. That's the only difference between pointers and other variables. And you can sort of visualize it in your mind as an arrow going from a pointer to a variable. Like pointer is the source, variable is the target, right? That is one way of visualizing it, the relation between them. But there is no arrow per se in the computer. You only have these numbers. You don't have actual arrow as such. But for your imagination, you can use arrow. But otherwise, it is just that the value of a pointer happens to be the address of some other variable. So they are linked in that way. Okay. And how do you store the address of a variable in a pointer? What is the operator? Yeah. Ampersand. The address of a variable is stored in a pointer by placing an ampersand before the variable, right? Like this. So ampersand x will give you the address of x. You are storing it in a pointer variable. Similarly, how do you get the value at a target pointed to by the pointer? By using star, dereference operator. Ampersand is reference operator. Star is dereference operator. By putting star before a pointer variable, you go to the location which the pointer is pointing to and extract that value. So that is dereference. All right. And when you increment a pointer by whatever number, +1, +2, whatever, depending on the kind of pointer it is. If it is an integer pointer, that +1 will become +4, 4 bytes. If it is a character pointer, +1 will remain +1 because character size is 1 byte. If it is a long int, +1 will become +8. All right. So depending on the data type it is pointing to, the increment in the pointer is multiplied by the size of the data type which it is pointing to. All right. So if it is an integer pointer, +1 means it goes to the next integer, not the next byte, next integer, which means it should jump by 4 bytes. If it is a character pointer, it should go to the next character, which means it should jump by 1 byte because the current character occupies only 1 byte, right? Like that. And we also looked at pointer to array. Array in itself is nothing but a pointer. All right. So when we say a of 4, so basically the name a is a pointer because that is a variable whose value is the address of the first element of the array. So that is what a is. That's all. So a itself is a pointer. It stores the address of the first element in the array. It is through that address you can access all the other elements in the array because you know the size of each element and you know the address of first element, so you can access any element. That is how an array is sort of structured and the access to the array is given. Right? Now, you can create an external pointer to the array like p. It can point to say second element of the array, first element, third element, 10th element, it doesn't matter. That is a free pointer that can point to any element. You can make it point to any element in the array. And you can change that p also. Right now it's pointing to the second element, later it can point to third element and 10th element or whatever. Or it can point to an entirely different array or entirely different variable also. It's up to you. That is a free pointer. But the array name a, that you cannot change. That is a constant. Array name is a constant. You cannot increment it, you cannot change it, you cannot make it point to any other location. Because if you do that, even if you increment it, you have lost access to the beginning of the array. Because once you change its position, you don't know the history, how many positions it came forward or backward. what was the starting point? Is it 10 elements before or 100 elements before or 1 million elements before? You don't know. So it is always fixed to the starting point. So the array name is a constant. You cannot change it. So a plus plus will not work or a minus minus will not work because that is constant. But if you have a separate external pointer to the array, that pointer can be changed. P plus plus, P minus minus, whatever, that can change. Okay. And yeah, this we saw. I won't spend much time on that. All right. So these are the things which we saw in the previous two lectures. Today we will look at a couple of more concepts. You see, suppose I don't initialize a pointer. I'm just declaring a pointer, integer pointer. I'm declaring. I'm not initializing it. I'm not storing the address of any variable here. I'm just declaring it and leaving it. Now, if I print its value, any idea what will it print? No, not location of P. I'm not saying star P or ampersand P. I'm just saying P. When you say print percentage dx, what will it print? Location of x? No. Value of x it will print. Similarly, you're just saying print percentage P, P. It will print value of P, not location of P. So what will be the value of P? Some garbage value, one answer, yeah? No value. Uninitialized. Right. So let us see. It's just warning, it's not an error. It's saying nil. This is another form of what we call as null. So a null pointer. So this is a null pointer. So an uninitialized pointer, or you can also call it as a dangling pointer. It is not pointing anywhere, right? Those are called null pointers. So this value null, it's like it's like you have some pointer P variable, its value is null. Its address may be some address, 1000 or something else. So this null, basically in the memory, null itself can't be stored, it's a word. You have to store numbers. So this null is nothing but the decimal value 0. This is the same null when you use in a string, the null character which terminates the string. Same null. That's its ASCII value is also 0, right? Right? So this is null. So null is like a special keyword. So it can stand for a null character or it can stand for a null pointer. Just ASCII value is 0. That's all. So when a pointer is not pointing anywhere, that is called a null pointer. So you cannot dereference it. What will happen if you dereference it? Dereferencing means what? Visualize. A pointer is pointing somewhere, which means there is an arrow from the pointer to the variable which it is pointing to. Dereferencing means you go to the target of the arrow and extract that value. Now, if there is no arrow itself, how can you dereference? Right? It's like, so let's say I say int x equal to 5 and I say int star p equal to ampersand x. So imagine I have x and its value is 5, say its address is 200 and I have a pointer, its value is 200. Its value will be address of x. Its pointer's address may be something. Okay. Now since the address of x happens to be the value of p, you can imagine a pointer going from p to x. So when we say dereference, so when we say star p, what is it doing? It moves along this arrow, comes here and extracts this value. That is star p. All right. Now, what if the pointer, what if there is no arrow at all? What if this pointer's value is null? Then if I say star p, what will happen? It will just give an error. It cannot dereference. It's not that it will give a random value. It cannot dereference in the first place. There is no arrow for it to go along, right? So it will give an error. All right. So let's just test that. So here I just printed the value of P. Suppose if I try to dereference it now, I should use star P, right? Dereference point operator is star. And since this is an int star, I will be printing an integer, assuming you're able to dereference. All right. Error. So when you printed P, it is null. But when you try to print star P, it is giving an error, segmentation fault. Okay, because it is unable to dereference. There is no address stored here. Where do I go? There is no arrow. What do I follow? Which path do I follow? No arrow. No arrow. Okay. So we will see the use of null pointers later. Usually, say if you don't want a pointer to point anywhere, then you manually initialize it to null. How do you do that? This is how you do. Suppose initially I say int x equal to 5 and I say star p equal to ampersand x. Now I don't want this pointer to point to x. Okay. Now it's pointing to x, right? Now I don't want it to do that. I want to remove that pointer. So simple way is say p equal to null. All right. Now let us print these again. Okay. So we can say after making the pointer null. You see, initially pointer's value is the address of x, and then star p is value of x. All right. And after making the pointer null, pointer's value is nil, and star p is segmentation fault because now it is not pointing anywhere. Earlier it was pointing to x. Now I changed that. I made it to not point to anything. Okay. We will see some other use cases of null pointers. All right. Another pointer is called void pointer. Another type of pointer, that is a void pointer. So void pointer, it's not that it does not point anywhere, it can point somewhere. But it doesn't know the data type of the address which it is pointing to, data type of the location which it is pointing to. So let us first try to print its value. Right now it is nil because by default, if you don't give a value to a pointer, it will initialize it to null. It is like any variable. Suppose if I just say int x, instead of say int x equal to 5, I just say int x. If I don't initialize it, it will by default initialize it to 0. Most of the times. It may initialize it to random value sometimes, but by default, it usually initializes it to 0. That is what happens with array also. You initialize the first few elements, the remaining elements are initialized to 0 by default. Right? Similarly, for a pointer, if you don't initialize it, it is initialized to null by default. But if you initialize it, you will get some value. All right. In this case, I didn't initialize, so it is not pointing anywhere. Okay. Now, what I can do, I can create, say, some integer, and I can make this pointer point to that location, p equal to ampersand x. Right. Now, if I try to print star p, do you think it will work? So what is happening? So I have int x equal to 5 and I say p equal to ampersand x, but this is like void star p equal to ampersand x. All right. So this is similar to the previous case, x 5 some address. This pointer is void star, its value is that of x and its address is something. It is pointing to this. That is fine. But if I dereference it, will it print 5? Exactly. It will come here, but then it does not know whether it's pointing to an integer or character or float or long int or short int. It does not know. It only knows the beginning address. You see this 5, it actually takes 4 bytes, right? This 5 is stored in binary across 4 bytes. But I'm pointing to the first byte. I don't know how many bytes I should treat as a block. Should I treat 4 bytes as a block? Should I treat this byte as a block, 1 byte as a block? Should I treat 2 bytes or 8 bytes as a block? I don't know. So I need to know how many bytes should I group and convert to decimal, right? Basically, what are we doing? Integer or character or whatever it is stored in bytes. But since we know an integer takes 4 bytes, we will read all the 32 bits as one number and we will convert it to decimal. But if we think it is not an integer but a character, we will take only 8 bits and convert it to number. So we need to know how many bits to take. Should I take 8 bits or 16 bits or 32 bits or 64 bits? Without knowing that, I can't convert it to a number, right? So I need to know how many bytes to group. That is the reason we have data types, right? Why do we have int and char? It's because when I know something is a character, I will take only that 1 byte and convert it to decimal. If I have something as integer, I will take 4 bytes, all these 32 bits as one number. I will not take these as 4 different numbers of 8 bits each. All the 32 bits correspond to one number. And I will convert that entire 32-bit number into a decimal, right? So this I'm able to do because I know the data type. If I don't know the data type, I don't know how many bits to take, how many bits to group, right? So if it is a void pointer, basically it means you don't know the data type of the pointer. You don't know which data it is pointing to. Is it pointing to a character or an integer or a float or long int or short int? You don't know any of that. So you need to specify what is the data type it is pointing to, so that it will take that much data and convert it to decimal and print it, right? So first let me print this and show. I'm not converting it. I'm directly trying to print star p. Let us see what it will do. It's giving error. It's saying invalid use of void expression. Why? Because this is a void pointer. I don't know its data type. If it is an int pointer, I know it is pointing to an integer. So I will go to that address and I will take 4 bytes. If it is a character pointer, I know it's pointing to a character. So I will go to that address and I'll take 1 byte. If it is long int pointer, I will go to that address. I will take 8 bytes. So I need to know the data type of this pointer. This is a void pointer. What is it pointing to? Is it pointing to int or char or whatever? I don't know. I need to specify that explicitly. I need to convert this void pointer into the specific type of pointer which it is pointing to. Okay. So how do I convert this pointer into a specific type? So here also you have type conversion, like how you convert float to int or int to float or cat. Yeah, basically float to int into float. You have type conversion, right? Similarly here, you convert this void pointer by putting int star before it. All right. Now I just don't want to print p. I want to print the value at the target of p. So I will put star before this. I convert void pointer to int pointer and then I dereference it. Got it? You can't dereference a void pointer. You don't know the data type. You first convert its data type into whatever type you want. You want to convert it to int star, convert it to int star. You want to convert it to char star, convert it to char star. Once you convert that, now dereference it. Now put a star before it. Okay? Now it should print the value of x. It printed. Oh, I said percentage %p. Let me change it to percentage %b. You see? So initially p was null. Then I made p point to x. Then I converted, because I know x is an integer, I converted p to int star and then I dereferenced p. Now the same void pointer can point to a character also. Then I need to convert it to char star and then dereference it. Right? So let's do that. So I can declare a character, say some character, and I will say p equal to ampersand ch, and here I want to print it as character. Here what should I write? Char star. That's it. But this is not possible if you declare p as say int star to begin with. If you say p is int star, then you can't assign character address to int star because p's data type is fixed. But since here p is a void pointer, you can make it point to any data type. If p is a particular type pointer, int pointer or char pointer, then you can't make it point to a different data type. But here, since p is a void pointer, it can point to integer, or it can point to character, or it can point to anything. All you need to do is you tell the kind of data it is pointing to while printing it. Okay? You see, initially it is null, then I made it point to x, then I made it point to ch. So when I made it point to x, I said it is pointing to an integer, so this becomes an integer pointer. So convert it to int star, and now dereference it. Then when I made it point to ch, then I said it is pointing to a character, so this is of type char star. So convert it to char star and then dereference it. That's what we did, right? You see, initially it is not pointing anywhere, so it is null. So this is null. Then I made this p point to x. Now since I know x is int, I want to convert p to int star. I did that. After converting it, I dereferenced it. All right. Then I made p point to ch, which is a character. Since I know ch is a character, I converted p to char star, and then I dereferenced it. Right? That's all. Now let us see why and where. I mean, further use cases of these null and void pointers. Okay. So far we have seen how to create array normally, like using a simple statement like int a of 5 or a of 10 or whatever. We did not worry about how much memory is needed, where this memory goes, and how to free this memory. Right? Imagine, suppose I have an array of size 1 million. Now say I want to add just 2 more elements to this array. How to do it? I want to increase this array size by 2. I want to add 2 more elements. How to do it? Sorry? Inside square brackets, what do I do? Array size is fixed, 1 million. It's filled already. Now I want to add 2 more new elements, which means this 1 million is not enough. I want to increase the size of the array. What to do?
Take the previous array into new array.
And new array size is?
New array size is 1 million plus whatever you want.
Right. So there is no way of modifying the original array itself. I can't increment the original array. I have to create a new copy entirely of size say 1 million plus 2 and copy all the previous 1 million elements into the new array and additional 2 elements. That's all. So your entire space is being wasted, time is being wasted, space is being wasted. And second thing, bigger thing, you can't even delete the previous array. Now that is of no use, right? I got a new array. The previous array is of no use, but I can't delete it. It is not in my hand. All these are being done at the back end by the compiler itself, and it is using something called stack memory. There is something called stack memory, something called heap memory. We will not get into much details, but let me tell you briefly. Stack memory is where your variables, functions, and other parameters are stored, and it is limited and it is quick, automatic. The compiler will take care of that. You are creating a variable, it will find some empty space in the stack, create that variable there. You are creating an array, it will find some empty space in the stack, create the array there. So the compiler will take care of it. You need not worry how it is created, where it is created, and how fast it is created, how to delete it. You need not worry. The compiler will take care. But suppose your data is quite dynamic. It is increasing, decreasing, some new elements are coming, some old elements are being deleted. So your array size is constantly changing. In that case, it is better not to use an array. You will find out later in data structures course. It is better to use linked list. But linked list, you don't have a command, single command to create a linked list. It is not a data type. It's a derived data type. Array is a derived data type, but you have a single command to create an entire array. But you don't have a single command to create an entire linked list. You don't have inbuilt data type. You need to create that. Okay. And you need to allocate the memory for the linked list manually. And this memory, which you allocate manually, is created in something called heap memory. It is not created in stack memory. Heap memory, these are both two divisions in the RAM. Heap memory is not limited. I mean, heap memory is much bigger. It's not as small as stack memory. So you have much more memory, but it is not automatic. You need to manually create the memory and also destroy the memory once you are done with it. If you forget destroying the memory, it remains there, and that is not used by any other process. That is wasted. So it is better you destroy that memory once your job is done. Otherwise, it will lead to something called memory leak. So if you are using dynamic memory, or if you are using scenarios where you are creating the memory, that memory will be stored in something called dynamic memory. You need to create that. It is not automatic. You need to delete that. It is not automatic. So for ever changing memory scenarios, it is better you create the memory, you destroy the memory. And so we have commands for that. Those commands we will just see today. You will understand the use of these commands later when we get to struct in this course, and much further when you get to linked lists and other data structures in the data structures course. Okay. So right now, another reason is struct. I'm just telling you briefly. You will understand better when we get to struct. Struct is a heterogeneous data type. Array is a homogeneous data type. Only array of integers or only array of characters. You can't have some integers, some characters, some floats in an array. No, all elements should be of same type in an array. So that is a homogeneous derived data type. Struct is also a derived data type, but it is not homogeneous. It's a heterogeneous one. That is, it can be a mix of some integers, characters, float, and so on. I can create a struct. Imagine a simple example is, suppose I want to store the data of a student. Each student will have multiple different kinds of data type: name, age, roll number, address, parents' name, all these. So one is a string, another is a number, another is a float, or marks in a subject. All these are different data types, but all these are stored in one sort of bigger data type, derived data type. That is called a struct. That's a unit. So a student is like a unit for me, within which I have some integers, I have some characters, I have some floats. So this, there is no single command which sort of creates all these data types together. I need to create that, and I need to give memory for that. I need to allocate memory for that. All right. I need to sort of calculate how many bytes it requires, and I need to allocate so much memory for that. Because if it is, say, 2 integers, 1 character, 3 floats, then how much it is? 2 integers means 2 into 4, 8 bytes, plus 1, 9, plus 3 floats, 3 into 4, 12, 9 plus 12, 21. So this takes 21 bytes, one struct, one instance of a struct takes 21 bytes. It doesn't map to any known data type. So I need to allocate 21 bytes for this particular student to store this particular student's data, right? So there are such scenarios where you want to customize the memory which you want to allocate, and you want to free it later, right? So for those scenarios, the known data types won't work. Arrays or normal variables, they don't work. You need to allocate the memory. All right. So we use 3 most used functions: malloc, calloc, and prealloc. Realloc. So malloc is nothing but memory allocation. And the syntax of malloc is void star malloc number of bytes. So like in the previous example, suppose I want a memory that can store 21 bytes of information, right? Then all I need to do is say malloc 21. All right. Now what it will do? It will create a block of size 21 bytes and return the pointer to the first byte of this block. So this block may start somewhere in the RAM. Suppose it starts at maybe say some number 300. This is the first byte. And then there are 21 bytes. So it ends at 320. All right. So there will be a pointer pointing to this first byte, right? 320 address. So this pointer's value will be, 300. This pointer's value will be 300. So this pointer will be returned by the malloc function. But this pointer is of type void star. Its type is not specified beforehand because the computer doesn't care what you will use this memory for, whether you use this memory for storing 21 characters, or whether you will use this memory to store 5 integers and 1 character, or whether you will use this memory to store 2 integers, 1 character, 3 floats. It's up to you. The computer doesn't care. So it will just return your anchor. That is the pointer. It will return to you. You convert this pointer to any type you want. It is just a void pointer for me. I am giving you the handle. That's all. I'm allocating memory and I'm giving you the handle. You decide what kind of data you want to store in this. All right. The complex combination like some integers, some characters, some floats, that we will see when we get to struct. But we can also use this memory to store homogeneous types like 21 bytes. So we can say 21 characters. Right? We can say that. Or suppose if it is 20 bytes, let me make it simpler because we will discuss integer examples. 20 bytes, that is, so it ends at 319. It starts from 300 and goes up to 319. These are 20 bytes. All right. So 20 bytes of space in which how many integers can I store? 5 integers, right? So let's imagine I want to create an array of size 5. One way is I directly use the command int a of 5. But suppose I don't want to use that. I know that I want to delete this array later. Okay. Or suppose I want to create an array of size 1 million and I want to delete that array later. In that case, I cannot use that array command directly int a of 1 million. It will not be deleted later. So for me to be able to delete it, I will allocate the space and I will delete it later. All right. So right now, let's take a smaller example. So 20 bytes. And this will allow me to store 5 integers. And I know I want to store 5 integers. So what I will do, I will convert this pointer. This is a void pointer. It will return me void pointer. So I will convert that void pointer to integer pointer. All right. And I will store that integer pointer in some variable p. Or either I can do it in 2 lines or in the same line I can say int star p. During declaration itself, I can do initialization as well. Int star p equal to, so you assign some memory to p during declaration itself. That's it. And now since you also said it is int star, it will be pointing to an array of integers. Each element in this array has to be an integer. So now when you do p++, it will move to the next integer. Or when you say p of 2, it will go to the third integer in this array. P of 3 will be the fourth integer. P of 4 will be the fifth integer. Right? So now you can treat it as an array. This is another way of creating an array. All right. You assign a block of memory, and if you know that data type which you want to store in this array, convert the malloc return type to that data type pointer and assign that to your pointer name. Because malloc doesn't give you name. It just gives you void star. It doesn't give you P or Q. You need to store it somewhere in P or Q. Right? That's all. All right. So let us first see this. And to use these functions, you need to include a library called stdlib.h. I'll just say int star p equal to malloc 20. And malloc will only return me void star. I need to convert it to int star because I'm assigning it to an int star. Otherwise, it will give an error. You're trying to assign void star to int star. Right? So I need to convert it to int star and then assign it to int star. Fine. Now I got an array. I got the size. It is equivalent to above step is equivalent to int p of 5. 5 integers. That's it. Now I got an array. I will populate it. I'll just populate it with some, say, I will say p of I equal to, say, 2 into I. It's like it will store 0, 2, 4, 6, 8, just for quick usage. And I'll print it. All I need to do is okay. I populated the array and then I'm printing it. That's it. You got an array, right? Now, usually, whenever you create a memory block using malloc or calloc or realloc, you should always delete it at the end using this command free. Okay, so this will free that memory so that some other program can use. Otherwise, this memory will sort of keep hanging around. Even after your program ends, this memory will keep hanging around. Other programs, this memory should be freed for other programs manually. All right. Same thing. You will not find any difference, but at the back end, that memory is free. All right. Now the same thing. Suppose I know this is 20 because I know there are 5 integers and the size of int is 4 bytes. Suppose I don't know what is the size of int, or I'm not sure if the size of int in this particular architecture is 4 bytes. It may be 2 bytes. It may be 4 bytes. It may slightly change from architecture to architecture. So in that case, you can write it as number of integers into size of int. So that the computer itself will decide if the integer is 4 bytes, it will allocate 5 into 4, 20 bytes. If the integer size is 2 bytes, it will allocate 5 into 2, 10 bytes. So let it decide whether it's 20 bytes or 10 bytes, leave it to that. You just tell how many integers space you want and use the size of function. Let it decide how many bytes it should give. You need not worry about the actual number of bytes. You just worry about number of elements and the size of each element. But finally, basically, you're giving one number only, one argument only. You're just dividing it, breaking it as a product. That's all. All right. So all right. Okay. Now, in calloc, the only difference between malloc and calloc is in calloc you have to give 2 arguments. That is the number of elements and the size of each element separately. You necessarily have to give them as 2 arguments. You can't give number 20. In malloc, you have to give only 1 argument. That 1 argument you calculate the final product and give, or you give it as an product expression. That's up to you, but it is 1 argument. In calloc, you have to give it necessarily as 2 arguments. All right. So let me quickly show you the examples. So this is the basic syntax of all the 3. So in malloc, I am initializing an int pointer that is, say, array malloc, and I am creating an array of size 5 integers, right? And I'm giving it as a product 5 into size of int. That's all. But in calloc, I am giving 2 arguments, number of elements and size of each element. That is the only difference between malloc and calloc. That's all. So you can just use malloc if you, I mean, instead of saying 5 comma, you are just saying 5 times. Both are same. All right. In realloc, what you're doing, you are taking the previous block and you are resizing it. Got it? You are taking the previous block of size 5. Say I want to increase it to size 10. So I take the previous pointer to the previous block, array malloc. That size was 5. It's like an array of size 5. But I am making it an array of size 10. So realloc is to resize an array. That's all. All right. And at the end, you need to free all these three. All the 3 pointers, 3 blocks. Okay. Fine. All right. Now, another use case is we can use only pointers to deal with any level of arrays, not only 1D arrays. So far, we just saw 1D arrays, array of 5 integers or something like that. 2D arrays is nothing but what we usually call as matrix. Matrix is nothing but 2D array, right? A of 4 by 5 is 4 rows and 5 columns, like that. And so on. We can have a 3D array, 4D array, ND array, multi-dimensional arrays we can have. So those are like multi-dimensional matrices, right? And we can deal with all these using purely pointers. No need of array syntax also, because even array syntax is finally converted to pointer syntax. So we are going to the fundamentals. We are understanding the fundamental syntax in terms of pointers. All right. So let us understand how to create matrices using double pointers. So far we use single pointers. Matrices require double pointers. So what is a matrix? So let's imagine I have 3 rows. And each row has 5 elements. You can think of a matrix as array of arrays, right? Each array is an array of integers or array of characters, whatever it is. But a matrix, 2D matrix, is nothing but array of arrays, right? 3D matrix is array of arrays, and so on, right? So imagine I have, say, int star p1 pointing to this array, and int star p2 pointing to this array, int star p3 pointing to this array. All right. Each array is a row in matrix, right? But right now, I don't know whether all these 3 arrays belong to the same matrix or they're just 3 independent arrays. P1 is some array, P2 is some array, P3 is some other array, right? I don't know. If I want to treat them as one matrix or 3 rows of the same matrix, then what I need to do is I need to create an array for these 3 int pointers. Okay, and the pointer to this array of integer pointers will be int star star p. You can mean star star q also, anything is fine. So this will be pointing to this array, and each of these elements will be pointing to each of these rows. You're getting it? This much you understood. This is like single arrays. You already know that each pointer, each integer pointer is like a pointer to an array, right? That is quite simple. Each row is nothing but an array. In a matrix, each row is an array. So you can have a pointer to each row. All right. Now, how do we treat all these 3 rows as rows of one matrix? That is by sort of combining them. But I can't combine the rows as such. I can combine the pointers of these rows. The pointers of these rows, I can put them in an array. And I can create a new pointer for this array. So you need to think of 2D means what? 2 dimensions. You can think of it as x-axis and y-axis, right? So each row pointer will give me the array in x-axis. But the double pointer, which points to the row pointers, will give me the anchor to each element in the y-axis. All right. So if I have to dereference the pointer and reach an element, first I will dereference the double pointer. This int star star p is a pointer to pointers, right? So if I say star p, it will give me one of these elements. I mean, star p will give me p1, but if I say star of p plus 1, it will give me p2. Star of p plus 2, it will give me p3. Yeah, I'm getting some murmuring. Please be quiet. Can you switch on the lights? Jenu? All the lights. Switch off these screen lights and switch on all the lights. Yeah, so the first level of dereference will give me access to one of these pointers. And when I come to any of these pointers, then if I use P of P2 of 2, it will give me access to each of these elements. So first you dereference along y-axis, you reach any of the pointers, which means you are reaching a particular row. Once you reach a row, you dereference it further to reach a particular column or reach a particular element in that row. Okay, so that is how matrices are implemented actually. Okay, so let us do that. So initially, I want to create a pointer to the entire matrix, right? That will be a double pointer, right? Each row will have a single pointer, and then the array of these single pointers will have a double pointer, right? So first I will say int star star p, and I need to allocate this memory first, this memory. So in this memory, how many pointers I have? How many integer pointers I have? 3. So here, what do I say? Malloc 3 into size of, are they integers or int pointers? These are integer pointers, right? They are not integers. I'm not storing 3 integers. I'm storing 3 integer pointers in this array. So size of int star, right? If you are storing integers, it should be size of int. If you are storing integer pointers, it should be size of int star, right? And for this array, what it will return? Void star. But what I want, pointer, is it a single pointer or double pointer? Double pointer. So I should convert it to int star star. All right. So now I got an array of integer pointers. Now I go to each integer pointer and I should create this memory also. For P1, I should create this array. For P2, I should create this array. For P3, I should create this array memory. And then I can assign values, right? So for int I equal to 0, I less than 3, I plus plus. P of I equal to, it means P of 0 is an array, P of 1 is an array, P of 2 is an array, P of 0 is a pointer to integer array, and so on. So here you say malloc, how many integers in each array? 5 into size of int. And what should it return? Int star. P of 0 is an integer pointer, P of 1 is an integer pointer, each row it's an integer pointer, right? That's it. Now I will print them. I mean, I will allocate some values to them and then I will print. All right. They should go from 0 to 4, right? 3 rows, 5 columns. So we will say P of So each element, I want to assign a value. How do I access each element? One is star or array notation. In array notation, how do I access? In array notation, how do I access each element in a matrix? P of ij. That's all. P of ij. Right? It's like P of, so this is like P of 0, this is P of 1, this is P of 2. So P of 0, 2 will give me this element. P of 1, 3 will give me this element. P of 2, 0 will give me this element. And so on. P of ij will give me the element in the ith row and jth column. That's all. Right? So let us initialize them to something. Let's say I into j, some value. It doesn't matter. And I will also print the value P of ij in each row, and at the end of each row I'll print a new line. All right, now let us see. That's it. I created a matrix using only pointers. All right. You can use either star notation. You can say star p plus I, or you can just say p of I. Right? You can use any notation. Okay. So this is an example of 2D pointers. Similarly, 3D and so on. You need to practice. You need to practice problems. I already shared resources, different resources. So go there, practice different kinds of problems. Only when you practice, you will understand how much you understood. Otherwise, when I'm teaching, it may seem that you understood, but only when you start coding and when you make mistakes, you will understand what are the limitations, right? So please practice. Pointers is a tricky concept. Only through practice, you will get clarity. Otherwise, it's very difficult. Any doubts so far? So let me show you the real code. So in this, I mean, this is a slightly larger code. It's not only for matrices, but to give you an example of malloc, calloc, etc. This is an example where null is useful. You see, malloc, suppose you are trying to allocate a very big chunk for your array, say 1 billion or 1 trillion cells. And suppose that size is not available in the RAM. Then what will it do? It cannot return a pointer because it didn't even create that memory, allocate that memory. So it will return a null pointer. So if you get back a null pointer from malloc, it means that memory is not allocated. All right. So that is what this check is about. So if int array is null, which means if malloc return null, then you say allocation failed. Okay. If it is not null, it means it allocated the memory and returned the pointer. If it didn't allocate the memory, it will return null. So before you dereference your pointer, you need to check if it is null or not. If you try to dereference null pointer, you will get error. If it is null, you can't dereference anyway. So just say print some error message and exit. If it is not null, then you dereference and do whatever you want to. All right. So this is an example where null pointer is useful. Okay. And in this is the matrix. So here they are trying to create 10 by 10 matrix. All right. So in star star p, like what we saw in star star p, here calloc is being used. Anything is fine. We used malloc. Here calloc is being used. It is like 10 into size of int star in malloc. Here it is 10 comma size of int star. It is the first array, the y-axis array. You need to create array of 10 pointers first. So that is what is being created. Size of int star, right? And then if int matrix equal to null, return 1. All right. And once this y-axis is created, now go to each row and create an array for that. each pointer. So int matrix I equal to malloc size of int times 10. All right. Yeah. And say if you want to resize any particular array, you just, so here it is taking the first array, I mean single array, it has nothing to do with matrix. Okay, you resize it, change the size, give the previous array name, previous pointer name, and the new size that you want it to update to. All right, and finally free all these, all the arrays you created. Okay, so so this is about matrix. And just one more statement I want to add about null pointer and void pointer. You see, they contrast each other in quite simple way. Each pointer will have a data type and also a target. All right. If so, in void pointer and in null pointer, the difference is quite simple. In void pointer, you don't know the data type. You can have a target. It can point to something, but you don't know its data type. That is void pointer. In null pointer, you know the data type, but it does not point anywhere, because it is a dangling pointer. It does not point anywhere. Like I can say int star p equal to null. So this pointer data type is int star, but it is not pointing anywhere. If I find an integer later, I can make this p point to that. But right now, p is not pointing anywhere. Okay, so that is null pointer. So null pointer has something to do with the target. There is no target. Void pointer, there is no data type. Some pointer can be both. It can be both null and void. It doesn't. You don't know its data type. You don't know its target. Like we saw, void star p equal to null. That is also possible. Okay. So that is the difference between void pointer and null pointer. In malloc, because we don't know the data type beforehand, we just get the memory. So malloc just returns void pointer. You convert it to whatever pointer you want. So data type you don't know of malloc, but it is pointing somewhere. Target you know, which block, which address. It is returning the pointer to that block. You convert the data type which you want to. In null pointer, if malloc is unable to return anything, if malloc is unable to allocate any memory, it cannot point to any location. So it will just return null. So there is no target. So it will return null. Okay, and so on. Similarly, say you have a pointer which is pointing to some variable. You want it to not point to that variable anymore. You later change it to null. So initially you can say p equal to ampersand x. Later you can say p equal to null. Now p will not be pointing to x. So p can't access x anymore. That's it. I want to remove access to x. I will make p null. So these are different use cases of null and void pointers. All right. Yeah, you need to practice, otherwise you won't understand. Okay, so let's stop here.